Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take very easy Sudoku variant Sudoku puzzles and we break them down into detail so that you can learn how to Sudoku. Today's very easy puzzle is called Reuben by Full Deck and Missing a Few Cards. And here are the rules. Standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. Ratio pairs. Cells separated by black dots are in a 1:2 ratio. Not all dots are necessarily given. And these are also known as black Kropke dots. And basically, as an example, if this were a 2, this would have to be a 1 or a 4 to maintain the 1:2 ratio between the two cells. And that's how ratio pairs or black Kropke dots work. Sandwich sums. Clues outside the grid indicate the sum of the digits between 1 and 9 in that row or column. So basically, as an example, let's say you have, let's look at this row. Say we're gonna randomly put a 1 and a 9 together. So we have 1 and 9 here and here. The digits between these two digits, the cells between these two digits their digits must add up to whatever is outside the grid in that row, right? So these 4 digits must add up to 21 specifically. And obviously it can't contain another 1 or 9 because we already have the 1 and 9 in the row. And this does not, remember, the sum does not include the 1s and the 9. It's specifically the digits in between the 1 and the 9. And this is a typical sandwich clue. That's why it's called a sandwich, because it's what's sandwiched in between the 1 and the 9. So an example of this which would work would be, I don't know, 2, 5, 6, and 8, right? And this can be in any order, obviously. So it could be like 6 and 5. But 2 and 8 add up to 10, 6 and 5 add up to 11, therefore the full amount between 1 and 9 adds up to 21. And that's how sandwich sum clues work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so here's a quick well, we know that each row adds up to 45, right? Because of the digits 1 through 9, if you add them all together, it adds up to 45. What happens if you take out 1 and 9 from it? The remaining digits now must add up to 45 minus 1 minus 9, which is 10, which equals 35. And we have exactly a 35 sandwich sum. So therefore, the 1 and the 9 have to be on the outsides here. So therefore, we know this is a one of the posts. It's either 1 or 9, and this is one of the breads, shall we say. This is 1 or 9, or this is 1 or 9. So the ones in between cannot be a 1 or a 9 because we have both 1s and 9s in row 1. Well, this column adds up to 33. Now the thing is, what digits can add up to 33 in between 1 and 9? The only digits you can have to be 3, 4, 5, 6, 7, and 8. Everything but the 2, in other words, right? Because if you remove the 2, that means that the in-between sum has to be 33. So therefore, we know this specifically is a 2 because there's no other digit you can remove that makes the in-between cells 33. And we know this, so this is a 2, which means this is not a 1 or 9. But we know this has to be a 1 or a 9 because otherwise it's not going to add up to 33 in between, right? Because the remaining cells have to be in between the 1 and the 9 here. So since this is 2, this 31, similarly, you have 35 in between normally if you include everything. So this can't be essentially the 1 or 9. But this one, we know. So what can you take out that makes what's in between added up to 31? The only one you can add up or you can remove is specifically a 4. Because you can't add, if you try to remove 2 and 3, which are the lowest numbers, that gives you 5. So you have to remove 5 from the sum, which would mean 30. So this cannot be removing 2 from this, from in between the sandwich sums. I'm not sure if I'm explaining this well, but or clearly. But basically, this has to be a 1 or a 9, right? Because if you try to remove 2 and 3 from the in-between numbers, that would give you a sum of 30 or less, which is impossible, which does not fulfill this row's sandwich sum, because it's 31. So this must be one specific digit removed, and therefore this must be a 4. Now, what about this, right? If this were not, well, first of all, this is 26 in between the 1s and the 9s. So this cannot be the full set of digits in between the 1 and 9. So this cannot be a 1 or 9. Well, how do you remove 2 digits to get to 30? It has to specifically be 2 and 3, and you have to have, that's 3 in the corner. We celebrate because we know these two have to be the 1 or the 9 buns, essentially. Because if you remove 3 and 2, that leaves the in-between cells to have add up to 30, right? 4, 5, 6, 7, 8 adds up to 30. These 2 digits add up to 7. Well, how does that work in this column? This column has the in-between stuff adding up to 26. So if you have 35 minus 7, that leaves you 28, which means that we have to remove another cell from in between, which means this has to be not a 1 or 9, so it's not a bun, and it has to specifically be 2, so that the rest of the in-between cells can add up to 26. Therefore, this is a bun, and in addition, we know, again, this bun the in-between cells have to add up to 32. Well, you can only remove 1 digit now, which would make it work, which would make this a 3, right? Because the in-between cells have to be 35 minus this digit, which would be a 3 here. So these cannot be, obviously, in-between cells. These cannot be in-between, these can't be buns. These can't be buns. This can't be a bun, actually. And these can't be buns, because we already have 2 buns in each row or column, and this can't be buns. And none of these can be buns, right? This can't be a bun because we have 2 buns already in that box. Same here. This can't be a bun because we have two buns in this box already. Okay, so we know in between these 2 buns, it has to add up to 15. What are the only digits that can be there? It can't be 6, 9, because again, the 9 is one of the buns here, so it must be 7, 8. So this must be specifically 7 and 8. Let's see. Here in this column, this row, we have digits, 3 digits, which must add up to at least 3 digits, at most 3 digits. At most 3 digits adding up to 21. Well, what's the maximum of 3 digits? It's 6, 7, and 8 in between a bun, because you can't have a 9. 6, 7, 8 adds up to 21. Since it's the maximal amount, it has to be that specific amount. So this must be 6, 7, and 8. It's in between 2 buns then. So this is a bun and this is a bun, which means these two cannot be buns because we have two buns in each box already, which is essentially 1 and 9 pairs, right? So therefore, these cannot be buns. This is a bun, and it must have 4 in between another bun. So this is a bun then, also. And this cannot be a bun, and it must be a 4. We, therefore, where can this, in this column, actually, let's go here. How many digits can you have? We showed that the maximum of 3 digits in between a sandwich, in the sandwich clue, has to be 21. So therefore, the difference between the buns in this column has to be 4, because 23 is greater than 21. So you have to add at least a 4th cell in between the 1 and 9. Well, where are the possible cells that you could have 4 of in between a set of buns? It has to be these 4 cells, which these 4 cells then have to be in between 2 buns. We now know we have 2 buns in row 2, so therefore the rest of the cells can't be buns. We need 2 buns in box 3, so this must be a bun. And in column, well, we need 2 buns necessarily in row 5, so both of these are buns, because there are no other cells that could possibly be buns in row 5. And we know in column 5, the difference, the sum of the cells in between must be 4, which is a single digit that can add up to 4. This cannot be 4 because it has to be 6, 7, or 8. Therefore, the ones in between a bun have to be here. So this is a 4, which makes this a bun. Now we have 2 buns in that column, so this can't be there. That can't be a bun. This can't be a bun because we have 2 buns in that row. Therefore, this must be the bun, and it has to have an 8 in between. So therefore, this is 8. These can no longer be 8. We know this bun, again, is in a 1 to 2 ratio. It can never be a 9 because 9 can never be essentially a... it can never be double anything. And if you double 9, it has to be 18, which is not a digit. So therefore, these digits that are next to a black crop key dot, or a ratio pair if you want to call it, has to be a 1. So these are both 1s, which makes the other 9 in the box with it a 9. The other bun with a box. Or in the same row, it has to be a 9. So therefore, this is a 9, this is a 9, this is a 9. And we can alternate them between the 9s and the 1s. This can't be a 9, so this must be a 1. This can't be a 1, so this must be 9. This can't be 9, so this must be 1, which makes that a 9. This is a 9, so this can't be 1. Or sorry, this has to be 1. This can't be a 9, so this must be 1. This can't be 9, so this must be 1, which makes that a 9, which makes that 1. This is a 1, which makes that a 9, and therefore that's a 1. So that's how you fulfill... That's why I used the buns, essentially, in place of essentially a 1-9 pair, because eventually you'll figure out that you have to have a 1 in certain places and a 9 in other places. And that's specifically given by the ratio pairs. Now, 1 is in a 2 to 1 ratio only with 2. Therefore, this must be 2, and this must be 2. What are the remaining cells here? It has to be 2, 3, and 5 in box 5. And we number the boxes in typical Western reading notation. So that's top to bottom and left to right. So this is box 1, box 2, box 3, box 4, box 5, box 6, 7, 8, and 9. And that's just a convention so that we can easily talk to other people about how things work. Okay, so therefore this is also 2, 3, and 5 in box 5, but the 5 can never be next to a crop key dot, right? Because otherwise it would be, it cannot be double anything, and 5 doubled is essentially 10, which is not a digit. So this is 2 or 3. 2 could be next to 1 or 4, but 1 is already taken care of, so this must be 4 if this is a 2. This could be 3, and if this is a 3, this has to be a 6 then. This cannot be anything but 5, 6, 7, or 8. So 5, 6, 7, or 8 are here in the remaining cells. Again, 5 and 7 cannot be next to a black crop key dot, because if it is, 5 is not double anything, 7 is not double anything, and if you double 5 or 7, those become 10 and 14, which are not digits. So this has to be 6 and 8 specifically, and they can only be with 3 or 4. Let's take the remaining digits in column 6. Well, actually, no. Let's take the remaining digits in this row. We know that there are only 2 digits that are in between the buns, so therefore it has to be specifically 7 and 8, as we showed in this column here, right? Because you can't have 6, 9, because there's no 9 possible, so it must be specifically 7 or 8. Now we have a 7, 8, 7, 8 pair in row 3, which eliminates 7 and 8 from the rest of the row. Therefore, this can't be 7 or 8. It must be 5 or 6. Well, where's a 2 in row 3? It cannot be either of these cells because that sees a 2. It must be here now. So this is a 2. And the remaining digits are 3, 5, and 6. This can't be 3. Where is the 3 in row 3? It has to be specifically this cell, which makes this 5 or 6. This can't be 2 because of this 2, therefore this must specifically be 3, and therefore this is 6 to make a 1-2 ratio with it. This can't be 3 anymore, so this must be 4, and this has to be 8 to basically have a 1-2 ratio there. This can't be 8, this can't be 8. This can't be 2 or 3, so this must be 5. And to add up to 23 in between, this is 8 already. Therefore, the remaining digits is, again, 15, and we have 2 digits that add up, 2 cells that add up to that. So it specifically must be 7 and 8. So this is 7, 8, which makes that a 7. This 7 makes that a 6. This can't be 3 or 5, so it must be 2. And now we're probably, this adds up to 7 for this row, and it does not have a 2, so it must specifically be 3 and 4. Well, this can't be 4 because of this 4, so this must be a 3, and this is a 4. And I believe that's all. This can't be 6 or 7 because of this 6 or 7, so this is 5, which makes that 6, which makes that 5. This can't be 5 or 6, so this is 7. And yes, now we're probably just doing Sudoku, normal Sudoku rules. We have all the 1s and 9s set up. Where are the 2s? This can't be 2, and this can't be 2, because of the 2s that are here and here. So this must be a 2 remaining. The last remaining 2, then, in row 4, has to be here. So this is a 2. We have 8 2s now. Where's the last remaining 2? It has to be here, right? So if you ever have 8 of a certain digit, in normal Sudoku, you know exactly where the last digit is, because all the other 2s eliminate all the other possibilities. So this is a 2. What about 3s? Do we have enough 3s? Yes, maybe. We know this is a 3 because all the 3s here are eliminated, so this must be a 3, which forces this to be the only possibility for 3 here. We don't have enough information because we only have 7 3s now. Okay, let's continue. What are the digits that can be here? It has to be 5 and 6. This can't be 6, so this is 5, which makes that a 6. We only have 1 digit remaining here, so this must be an 8. 2 digits here have to be 4 and 6. This can't be 4, so this must be 6, which makes that a 4. This is only one remaining digit, and it has to be 4. These have 2 remaining digits. What can they be? It's 5 or 7, and this can't be 5, so this is 7, which makes that a 5. One remaining digit here, it has to be an 8. Here are 2 remaining digits, but that's could be many things. All right, specifically it could be 6, 7. So that's not helpful. We have 2 remaining digits here, and they cannot be 7 or 8 again because of the 7-8 pair. It has to be specifically 4 and 6. This can't be 4, so this is 6, which makes that 4. What are these remaining digits? It's 7 and 8, and this can't be 8, so this is 7, which makes that an 8. This is only one remaining digit left, so this is 5, and this has to be 8. The remaining digits here... Okay. What is this? This has to be a 6, because that's the remaining digit left. So we have 6 and 7 in this column. This can't be a 6, so this must be 7, which makes this a 6. This makes that a 7. That 7 makes this an 8, which makes that a 7. And this is all normal Sudoku, remember. Remaining digits for these 3 cells are 3, 4, and 5. This can't be 3 or 4, so this must be 5. Because it can't be 3 or 4 because of that 3 or 4. This can't be 4 anymore. It can't be 5, so this must be 3, which makes this a 4. Remaining digits here are 6 and 8, and this can't be 8, so this is a 6. This is an 8 because of this. 6 and 8. Remaining digits here are 3 and 5. This can't be 3, so this is 5. This is 3. Therefore, the remaining digits are 5 and 7. And that's how you solve it. Yeah, it's a nice introduction into sandwich sums and a lot of the logic that is required whenever you have sandwich clues. Right? Particularly, essentially, I like coloring them in as a certain color. And then if you ever have 2 buns, essentially, in a row or a column or a box, you can color the other ones as non-buns. Right? Anyways, that was a nice introduction. I hope you enjoyed this solve, and I'll see you next time on Learn How to Sudoku. Take care.